All right, kiddos. So this is going to be your lesson 25-2-3 uh, instructional video. And here's the essential questions we're going to answer in this video. What are the laws of exponents and radicals? Just a little review. How do we solve square root equations? And what is a cube root function? And what are the generalizations we can make about cube root functions and transformations? So let's dive right in. Let's talk about our laws of radicals first. So we learned all of these last year in geometry. Okay, so we have the product law of radicals that says the square root of a times b is equal to the square root of a times the square root of b. So if I had the square root of, I don't know, xy, that's equal to the square root of x times the square root of y. And if we look for a numerical example, the square root of 18, we could say that that's equal to the square root of 9 times the square root of 2, which would be 3 square root of 2. So that's the main thing that we use that law for. Okay, otherwise we have the quotient law, which we don't use a whole lot, but it is good to know. And it pretty much just says the square root of a over b is equal to the square root of a over the square root of b. Okay, and I shouldn't be saying square root, so let me back up. So this is for any radical, not just square roots, so the nth root, right? As long as the roots match, we can do this. Okay, so whether there's a 2 here, so I'll leave this as square root. So whether there's a 2 here or a 3 or whatever, it works for this. So these are laws of just any radical, not just square roots. Okay, so the nth root of a over b is equal to the nth root of a over the nth root of b. Okay, so for example, if I had the cube root of 64 over 16, right? Or here, let's not do 16, let's do 8. Okay, so the cube root of 64 over 8. That'd be the same thing as the cube root of 64 divided by the cube root of 8, which would be 4 over 2, which is 2. Excuse me. So pretty easy peasy and straightforward there. Okay, and rational denominators. So this is just that law of radicals that says we cannot have, for example, 1 over the square root of 2. If you remember from all the trig that we were doing, this is no bueno. We can't have an irrational denominator. And to fix this, we multiply by the bad number, quote unquote, on top and bottom, and we get something that is rational in the denominator. Okay, so really quick, let's go over laws of exponents. Okay, and these should be a super refresher. You should know these inherently if you don't know them just in an algebraic sense. So the product law of exponents says if I have x to the a power times the same x to the b power, that's just equal to x to the a plus b. In other words, if I have x squared times x to the third, that would be x to the fifth power. And we should already know this law. Okay, and that applies with regular numbers also. So 3 squared times, I don't know, 3 squared, that would be 3 to the fourth power, which would just be 81. Okay, so same idea there. Quotient law of exponents. So if I have x to the a being divided by the same x to the b, then I can rewrite it as x to the a minus b. Or an example with actual exponents. Okay, so this is x to the third over x to the first power. This would be x squared because 3 minus 1 is 2. And with actual numbers, I'll just use 3 again. 3 to the third power over 3 to the first power. This would be the same thing as 3 to the second power, or 9. And if we did the actual math, this would be 27 over 3, which is still 9. Okay? Power to power law. So if I have x to the a all being raised to the b power, okay, all this would end up being is x to the a times b. All right? And we could also say, you know, if I had x to the a, y to the b, and all of this was being raised to the c, this would be x to the a times c times y to the b times c. Okay, and an example of this, and you saw some of this on the getting ready assignment. So if I had 2x squared y, all being raised to the third power, well, this would be 8 x to the 6 y to the third. Okay, so just a little refresher there. Now we're going to introduce something a little bit new, fractional exponents. So basically, if I have, and I'll keep using a and b. So if I have, oops, x to the a over b, like this, so a fractional exponent instead of having x squared, right? This is equivalent to the bth root of x to the a power. Okay, so if I have x to the 1/2, like so, this is the same thing as the square root of x. It's x to the first power, and we're taking the second root. Okay, and I mean, you can also use it to simplify things like, so if I have the cube root of x to the 9th power, okay, if I invoke this law right here, well, this is x to the 9 over 3, which would just be x to the third. Or if I had, you know, the square root of x to the 6th power, this would be x to the 6 over 2, which is x to the third. Okay, so pretty straightforward there. And as a bonus, I'm going to go ahead and throw in negative exponents just really briefly. So if you ever have a negative exponent, okay, so if you ever have a negative exponent, so for example, 7 to the negative 2. All this means is it's the reciprocal of what it would be if it was a positive exponent. In other words, 7 to the negative 2 is equivalent to 1 over 7 squared, or 1 over 49. Okay, so if you ever see something like x to the negative 3, this is the same thing as the reciprocal of x to the positive 3. Okay, so just a little heads up there. We might see some of that later. Okay, so now let's talk about our next EQ and how we solve square root equations. Okay, so this first one's simple enough. Square root of x equals 2. So the square root of some unknown number is equal to 2. And just like solving any equation, you always want to use inverse operations. So what is the inverse of taking the square root of something? Well, that's just squaring it, right? And it's an equation, you have to keep it balanced. So what you do to one side, you do to the other. And the square root of x squared, they're inverses, so that leaves me with just x, right? And 2 to the second power, or 2 squared, is x to the, or sorry, 2 to the second power is just 4, okay? So let's look at a little bit more complicated of an example. And this is going to remind you a little bit of when we were solving absolute value equations. Okay, so what you want to do first is get the radical expression isolated, quote unquote. After that, you just square like we did here on both sides. Okay, so let's go ahead and do that. So I'm going to subtract 4 from both sides. Okay, then I'm going to square both sides. And that's going to give me x minus 3 equals 25. And then I'm going to add 3 to both sides. And that's going to give me x is equal to 28. Okay, and we can go ahead and check our work just to make sure. So if I throw a 28 in here, 28 minus 3 plus 4 equals 9. Okay, so 28 minus 3, well, that's going to give me 25. Okay, and then Square root of 25 is 5. And 5 plus 4 does in fact equal 9. So I know my answer is correct. Okay. So here, let's look at this third example, and this one's getting a little bit more complicated now. So now we see the fractional exponents I was talking about earlier. But x plus 1 to the 1/2, so let's do that one separately. X plus 1 all to the 1/2. Well, if we follow what we saw here about fractional exponents, okay, x plus 1 all raised to the 1/2 is the same thing as the second root, or the square root, of x plus 1 to the first power. So it would just be the square root of x plus 1. Okay, so don't ever let that throw you off. And you'll start to memorize this stuff. It'll start becoming just, secondhand to you. So we've got x plus, oops, not plus, what's wrong with me? X equals x plus 1 to the 1/2, aka the square root of x plus 1, plus 5. So again, we're going to try and isolate the radical expression. In this case, it's a fractional exponent expression, but it's still, we saw, it's a radical expression. So we're going to subtract 5 from both sides. So I'm going to have x minus 5 is equal to x plus 1 to the 1/2. Then I'm going to go ahead and do the inverse of raising something to the half power, which would be raising it to the second power. Okay, and by the power to power rule, you're going to see why it's going to cancel. So times 2 divided by 2, right? So that's going to leave me with x minus 5 all squared is equal to x plus 1. Okay, and we're going to go ahead and FOIL this guy. So we're going to have, I'm going to bring my work down here now. So we're going to have x squared minus 10x plus 25, because that's a perfect square, equals x plus 1. Let's go ahead and move everything to one side because it's quadratic now, and we want to set it equal to 0. So I'm going to subtract x and subtract 1. So I'm going to have x squared minus 11x plus 24 equals 0. And I can use AC grouping here. A times c would be 24. And 8 and 3, so I'm going to use -8, -3 here. So what I'm going to end up with, after I do the factoring, x minus 3 times x minus 8 equals 0. So that means x1 is equal to 8, x2 is equal to 3. So now I need to plug in and see which one of these is my actual solution, right? So only one of these will be the right solution, okay? So if I take x1, let's start there. So I'm going to take the 8. So 8 plus 1 raised to the 1/2 plus 5 should be equal to 8. 8 plus 1 gives me 9. 9 to the half power gives me 3. And 3 plus 5 does, in fact, give me 8. So this is my solution. Let's go ahead and just see. Let's just pretend, well, maybe it could have 2 solutions. It's, it can't, but just to prove the point. Okay, so let's go ahead and try it with x2. Okay, and actually here, I didn't mean to choose that color. We use yellow. Let's go ahead and try x2. Okay, so 3 plus 1 to the 1/2 power plus 5 should be equal to 3 if this is my solution. Okay, so 3 plus 1, that's 4. 4 to the half power is 2. 2 plus 5 is not 3. 2 plus 5 is, in fact, 7, obviously. Right? So what does that mean about this x2 here? This means this is an extraneous, oops, can't spell, extraneous solution, okay? So if you're solving a square root equation, right, and you come to a quadratic like we did here, okay, only one of them is the solution, okay? only 1 is the solution. In this case, our x1, 8, was our solution. Our x2, 3, was an extraneous solution. In other words, when we plugged it in, it didn't work. All right? Okay, so let's look at a couple more examples. Switch colors here. Okay, so this one's not going to be so bad. Okay, so we've got 2 minus the square root of x plus 1 is equal to negative 5. So again, we want to go ahead and get the radical expression by itself. So I'm going to add 2, or sorry, subtract 2. And that's going to give me negative square root of x plus 1 is equal to negative 7. Then I'm going to multiply by negative 1. And that's going to give me square root of x plus 1 equals positive 7 now, since I multiplied by negative 1 on both sides. Then I'm going to square both sides, and let me bring my work over here. I'm going to square both sides. That's going to give me x plus 1 equals 49. Subtract 1 from both sides, and that's going to give me x equals 48. Whoops, forgot to write the 4. Okay, straightforward there. And this last one is super easy peasy. So just looking at it, we've got 2 square root of x plus 4 equals 6. First thing I'm going to do is divide by 2 on both sides. Square root of x plus 4 equals 3. Then I'm going to square both sides. X plus 4 equals 9. Then I'm going to subtract 4. And I'm going to have x equals 5. Easy peasy. Okay, so now let's move into the next type of functions we're going to be studying and analyzing, and that's going to be cube root functions. Okay, so a cube root function, let me figure out which color I want to use, so I'll use red. A cube root, really? I thought I clicked on red. A cube root function looks like this right here. Okay, so f of x, and actually, here, let me write this over here. F of x equals the cube root of x. Okay, so instead of being a square root, instead of having a 2 or a blank spot there, we have a 3, letting us know that it is the cube root of x. And referring back to our getting ready, you had this as a problem. You had the cube root of 64, right? And the cube root of 64 ended up being 4. Why? Because 4 to the third power is 64. Okay, so they're inverses of one another. Okay, which brings us to our next function right here next to it, g of x here. So I've got g of x equals x to the third, and this is a cubic function. Cubic because we're cubing the function of x. Okay, and these two, blue and red, f and g, cube root of x and x cubed, they are inverses. And let's just prove that really quick. So what we're saying is that g of x is in fact the f inverse. Okay, and we can easily prove that. So if we take f equals the cube root of x, and we just do the flipperoo, so now we've got x equals the cube root of f. Whoops. Okay, we're just going to cube both sides. Okay, and that is going to give me f inverse of x equals x cubed. And we know f inverse of x in this case was this guy here. Okay, and another way that we can prove it is by looking at this graph here on the right. You see in green right here, we've got our h of x equals x, and that's a fancy way of just saying y equals x. Okay, and you notice that there's symmetry about the line y equals x, namely between f of x in red and g of x in blue. Okay, where g of x is x cubed and f of x is the cube root of x. Okay, so they're obviously inverses because we have obvious symmetry here between these two. Okay, so now let's go ahead and finish this off by just talking about how the transformations of cube root functions work. And they work very similar to what we saw with the square root functions and what we saw with quadratics and what we saw with absolute value functions. Okay, so what I'm getting at is, so A is our stretch or shrink factor, okay? When our absolute value of A is larger than 1, it's a stretch. When our absolute value of A is in between 0 and 1, in other words, if we have a fraction, we have a shrink, meaning that we're getting compressed, right? And if A is negative, we're going to get a reflection across the X or the Y axis. Well, why would I say the X or the Y axis? So let's say we had f of X equals the cube root of negative X, right? So what's going to end up happening if I use the law of radicals, the product law, so I'm going to have the cube root of negative 1 times the cube root of X. The cube root of negative 1, let's bring that over here by itself. The cube root of negative 1 is just negative 1. Okay, well, why is that? If I take negative 1 and cube it, meaning negative 1 times negative 1 times negative 1, okay? Negative 1 times negative 1, positive 1. Positive 1 times negative 1, negative 1. Okay, so the cube root of negative 1 is negative 1. Anyway, okay, if I have a negative in here, if this X is negative, that's the same thing as saying simply this, negative is outside, okay? And that goes back to the fact that the cube root of negative 1 is also negative 1. Okay, so these two expressions here and here are equivalent. Okay, so that's why I say it would be a reflection across the X or the Y axis. And you'll see what I'm getting at here in a second when I show you on Desmos, and click this link down here. Anyway, I digress. So B, our B term, well, that's our horizontal shift. Nothing new there. And I've got the little note for you there. So minus B shift right plus B shift left. Our vertical shift is C. Okay, and nothing new there. Adding makes us shift upwards. Subtracting makes us shift downwards. And before I end this video, let's look at Desmos really quickly. And of course, it's not going to open up correctly. There it goes. Okay, so let me just try to fit this to my little recording screen here. Okay, so referring back to A, right? So if A is larger than 1, obviously I'm getting stretched vertically. If A is less than 0, if it's negative, you saw what happened. Okay, I got reflected across both X and Y at the same time just because of the nature of the geometry of this function. Okay, if A is a fraction, meaning it's in between 0 and 1, in either side of the absolute value, we get skinnier, we get compressed or shrunk. Okay, so I'm going to put that guy back at 1. And B is our horizontal shift. Okay, if I am subtracting, I'm going to the right. However, if B is negative, that would mean that's a double negative, so it would become X plus B, right? I start shifting to the left. Okay, and C, obviously, that's just shifting us up and down. Okay, now let's look at what happens here. If I make X be negative on the inside, well, yes, I reflected, but if I just make A negative, holy dog crap, it looks exactly the same. Okay, so that just proves my little algebra that I did just now. Okay, so now that that's out the way, let's sum this all up. So we answered all 4 of these EQs. We answered what are the laws of exponents and radicals, like every single one of them. And we saw how to solve square root equations, and we learned about cube root functions and the transformational generalizations therein. Okay, so watch this video. Well, I don't know why I'm saying that at the end. But anyways, make sure you took good notes, ask a lot of questions over anything you didn't understand, and be prepared for tomorrow. Goodbye.